Hello, let's do part 2 for 7-7. So the relationship between numbers. What I mean by that is if we're looking at complex numbers, a plus bi, we have imaginary numbers, and we have real numbers within imaginary numbers. And so basically all numbers are also complex numbers. And so I really should have put complex here instead of imaginary, but we'll be okay. Okay. And the reason why all real numbers are also complex is 3, for example, can be written as 3 plus 0 I. So if we make kind of a little, I don't know, chart, I guess. If you have integers, they're also real. Sorry about that. And they're also complex. If you have real numbers, they're also complex. But if you have complex numbers, they're not everything else, okay? And so I'll show you what I mean. So if we look at the polynomial x squared minus 9, if we're looking for integers, that works. We can do x minus 3 times x plus 3. Well, looking over here, integers are also real numbers, so that's fine, x minus 3, x plus 3. And they're also complex numbers, x minus 3 and x plus 3. If we look at x squared minus 5, the only way we can rewrite this is x in parentheses squared minus square root of 5 squared. So meaning over the set of integers, we can't factor because square root of 5 is not an integer. But it's a real number, so we can factor over real numbers. And if we have a real number, it's also complex, so we can factor over complex. If we have x squared plus 36, that's like x squared plus 6 squared. Whenever there's a plus, you use i's, right? And so it's not integers, it's not real numbers, it's only complex numbers, x minus 6i, x plus 6i. So let's look at these. If you're feeling, that's not what I meant to do. If you're feeling comfortable with this, you're welcome to pause and just try it on your own, otherwise you can watch me. So x squared minus 7. Well, the only way to write this as a difference of squares is x squared minus square root of 7 squared. Okay, so that's real. X plus square root of 7, x minus square root of 7. It's not integers, but it can be complex. X plus root 7, x minus root 7. X squared plus 7 is very similar. X squared plus square root of 7 squared. Okay, so let's see. That is, well, it's not an integer. It's a plus, so we're going to have to use i's, so it's not real, so it's only complex. This is x plus square root of 7i times x minus square root of 7i. X squared plus 25 is x squared plus 5 squared. I see integers, but since it's a sum of squares, there's a plus in the middle there. We're going to have to use i's. So can't do real, can't do integers. It's got to be x plus 5i times x minus 5i. And finally, x squared minus 4 is x in parentheses squared minus 2 squared. I see integers, and it's a difference of squares. This will just be x plus 2, x minus 2. Integers are also real. And integers are also complex. So to follow this, I would say I use this little chart we made. Let's go to the next page. We're going to find all real solutions to x to the 6 equals 1 by factoring. And then we'll find non-real solutions too. So let's just start to factor essentially. So x to the 6th equals 1. I can't do anything like that with that, but if I subtract 1 from both sides, I get x to the 6 minus 1 equals 0, and that I can factor. It looks like I could do, there's a minus, so it's a difference. I could do difference of cubes or difference of squares. I'm just going to do difference of squares because I feel like it. So x cubed squared minus 1 squared equals 0. And so then this factors into x cubed plus 1 times x cubed minus 1 equals 0. And then these we can factor. So this is x cubed plus 1 cubed. This is x cubed minus 1 cubed. And so since this is a plus, we have our binomial and our trinomial, and it'll be plus minus plus. So we have x plus 1. First thing squared, x squared, minus the 2 multiplied together. X times 1 is just x, right, or 1x. The second thing squared, 1 squared is 1. And now looking at this difference of cubes over here, we have our binomial, our trinomial. It starts with a minus, so it's going to go minus plus plus. So x minus 1. First thing squared, x squared, plus both of them multiplied together, x times 1, which is just x, plus the second thing squared, 1 squared is 1. So now, basically, we can find all solutions, real and non-real. If we look at x plus 1, if we set x plus 1 equal to 0, we get x equals negative 1. So there's a real solution. If we set x minus 1 equal to 0, we get x equals 1. So that's a real solution. If we, let's see, let's find the solutions for x squared minus x plus 1 and x squared plus x plus 1. So we'll do quadratic formula. I'm kind of going to end up writing over the homework here, so ignore that because I write too big. So we have x equals negative b, so a negative negative 1, which is 1, plus or minus the square root of b squared, so negative 1 squared, minus 4ac, or 4 times 1 times 1, all over 2 times 1. So x is 1 plus or minus, this is 1 minus 4, so square root of negative 3 over 2. So 1 plus or minus, we can move the negative over and make it an I, right, outside the radical. So square root of 3i over 2. So we end up with 1/2, because we're splitting here, plus or minus 3 over 2 times I. So that has an I, so that's a non-real solution. Yep, so we have our real solutions. We got some non-real. And now let's do the other one. X squared plus x plus 1. X equals, sorry about that, negative b, so negative 1 plus or minus the square root of 1 squared minus, because b is 1, minus 4 times 1 times 1 over 2 times 1. So x is negative 1 plus or minus square root of 3, square root of negative 3 over 2. So bring this out, make it an I. So we have negative 1 plus or minus square root of 3i over 2. And we have to split this one too, and we get x equals negative 1/2 plus or minus root 3 over 2i. So those are all our solutions, both real and non-real. Make sure you do your homework and practice to make sense of this, and email me or come to office hours if you need anything. Have a good day.